Hey everyone, this video is going to be a guide to troubleshooting the headlights, side lights, and horn circuits of the Kiwa Q1 Hummer. So first off, I just want to mention at the end of this video, I'm going to be showing how you can hardwire these connections for your lights and your horn without using this cable. So for example, one of the people I was helping, their cable burned up, so they needed to replace the cable. You could make a new cable, you could get all these connectors and make a new one, but if it were me and I was in that situation, I would just hardwire everything and get rid of these connectors. In fact, I've done that on one of my other scooters, this one here, and I did it on this one simply just because I wanted to eliminate a bunch of connectors. This would be more durable, of course. I've got the wires soldered. There's no chance of any wire coming loose or breaking loose or anything like that. You know, this is solid. That's never going to be a problem. It's possible. I wouldn't expect you to have a problem, but it's possible. On wherever you've got connectors, there's a possibility of a wire coming loose or something like that. So again, if you're looking for just how to replace this cable, how to make a new one, or how to just hardwire it and bypass this cable, jump to the end of the video. Okay, so I got it open here, and I have the wires we're going to talk about laying on top of this gasket. This is a gasket I use to seal the scooter. So first of all, if you are having to troubleshoot this, it's ideal if you have some sort of a voltmeter, a multimeter, one that can measure voltage. In this case, the V on mine. Now see this, the V with the squiggly line over it, that's for AC, so this is DC we're measuring as a battery. So you want the voltage with the line and the dash line under it. And also you want to be able to measure resistance, which is the ohms symbol right there. If you don't have a meter, this video still may help you, because I'm going to go over this entire circuit here for the horn and the lights. So even just inspecting these wires, you may be able to find where the problem is. Just knowing where these wires are actually going to. I'm only going to cover this lighting and horn circuitry. If you're looking for like other connections on these controllers, I have other videos up showing the full connection of the controller. So for this video, again, we're just talking about the lights and the horn circuit, and that starts right here. If you find your cable off the controller where your alarm mounts on, right there, and also your display is kind of a three connector cable. There's your display cable, and like if you follow that red wire over, it goes to where your alarm mounts on. And if you follow the red wire from there, it goes to this third pigtail here, which is a 3-pin female on the controller side, and a 3-pin male on this cable side. Okay, so here you can see, here's the controller side, it's 3-pin female, and here's the side that's just plugged onto it, 3-pin male, but it's really only 2 pins. The middle pin is not used, and it has red and black wires, and that's coming right off your controller. Okay, this is the power into the circuit for the lights and the horn. It's DC power from your battery, whatever your battery voltage is, nominally 48 volts, but somewhere around that range. And you should be able to measure that when your alarm is turned off, so there's power going to the scooter. You should be able to measure your black probe on your voltmeter to the black wire, red probe to the red, measure DC volts, and you should be able to measure your battery at this point. If you're getting your battery voltage here, that's good. Then you know your voltage is at least getting to this cable. We're going to look at this as just from where the wires go and not really pay attention too much to the colors, because I've now come to find out there's some Q1s out there that just have red and black wires. It doesn't look like this one with the yellow and the green and the red and the black. It's just everything's red and black, which made it a little confusing, but in the end, the wires all went to the same place. They just weren't the same colors as what you see here. So don't get worried if your cable is all red and black or any other color. It doesn't matter. We're just going to follow the wires through, and then you'll know where the wires go and what they do. Okay, so first of all, I'm just going to plug this back onto our controller. Okay, so if we go through that connector, we should have if we measured for our battery voltage on that connector, that then means we should have our battery voltage going through that connector if the connector and these wire and connections are all intact. And that means we should have battery voltage positive on this red wire, negative on the black wire. Okay, so first of all, let's follow the black wires. That's the negative side, and that doesn't go to as many places, so we're just going to get that out of the way first. There's two black wires coming through here, so that's your negative, and one of them connects up to this connector, which goes to one of your side lights. It's a 2-pin male, and there's another one over here, also 2-pin male. Those go to your two side lights. The only other two connectors are 3-pin, so there's no way to get them mixed up. The 2-pin connectors, which are both male, one goes to each of your side lights. Okay, so again, that black wire comes in, it goes over here to this side light, and then you can see there's another wire coming out of there that goes back over to the other side light. So again, we have one wire that comes in, goes to one side light, and then comes back out and goes to the other side light. That's one of these wires. The other black wire just goes straight through, and it ends up on the middle pin of this connector here. Now let's take a look at that connector. Okay, so again, that black wire comes back over into the middle pin of this 3-pin male connector. The other connector is also 3-pin, but it's female. So we got the negative voltage coming right in from the alarm module right into this 3-pin male on the center pin. The cable it connects up to here is going to be, of course, the 3-pin female, and then the other one is a 3-pin male, so of course you can't mix them up. But this cable goes up to actually the horn light module, which is this thing. So this is the voltage going up to your horn and your headlights. However, that voltage is switched between, at your switches up here. So before it goes up this cable, those voltages have to go to switches. But only the positive voltage goes to the switches. The negative voltage comes straight in and goes straight to the middle pin of this connector that then goes up on the black wire on this side to the headlights and to the horn. So that's the negative side. Okay, so that's it. That's all the places where the black wires go. There's one that comes in, connects both the headlights to the negative voltage. The other one comes in and goes to the middle pin of this 3-pin male, which the mating cable goes up to the headlights and the horn. So your negative voltage is getting to your side lights, your headlights, and your horn. All you need now is to get the positive voltage there. So let's do that next. Let's follow this other wire out of that main connector, which is your positive voltage, one wire, and it goes one place. It goes to the middle pin of this other 3-pin connector, which is a 3-pin female. Okay, the mating cable for that is the 3-pin male, of course. So when that plugs onto there, and you'll notice my connector is broken there actually, but it still plugs on. So when you plug it on there, again, the red wires are positive voltage coming in from the battery, and that goes to the black wire, which is the middle wire on this one. And this cable goes up to your horn light, or your headlight, and your horn switch. Okay, so again, what we see here is our red power wire, positive coming in to the middle pin of that 3-pin female. Our 3-pin male plugs on it, so that red now goes to the black wire, which is in the middle. So that black wire now has our positive voltage on it. It goes up to the cable, and that black wire connects to both one side of your horn switch and one side of your light switch. Okay, so this is the inside of your switch module. There's the horn, there's the light switch, and you can see here's the cable coming up. You can see the black wire, which has our positive voltage on it, comes over and connects to that terminal of the horn. Then there's another black wire connected to that same terminal that then comes over here and connects up to the light switch. So again, black wires are positive voltage. It goes to the horn switch there, through another wire to the light switch there. So now both the horn switch and the light switch have the positive voltage on one side. Okay, so now you can see what happens. When we turn on the light switch, it connects those two terminals basically, so now the positive voltage is passing through the switch onto the green wire going back down the cable. So the headlight power is the green wire going back down the cable, and then the horn, if you push the horn button, it connects the power to that red wire. So your horn will be the red wire coming back down the cable. So that's how your voltages are switched. Comes up on the black wire, goes to one side of each of the switches. When you activate the switches, for the red side, the headlight, it comes back down the green wire, back down the cable. And for the horn, it passes it through and comes back down the red wire through the cable. So one of the people that I helped recently, the symptoms were his horn worked, but his lights didn't work. So I knew immediately that the voltage was here at the horn switch because the horn switch worked. But it wasn't coming back down the green wire when he activated the light switch. So that means this wire, the black wire, somehow was disconnected going over to the switch, or the switch was bad, or somehow this green wire is disconnected or open going back down through there, which is unlikely. I knew most likely the problem was going to be right up here, either a bad switch or one of these wires, either the green one or the black one on one side or the other being open. And that's what it was. The wire was broken off or loose or something on this side, which was preventing the lights from coming on. When he pushed this button, there was no voltage getting there because this wire was broken, so therefore there's no voltage getting down to the lights. Okay, so back over here. Now we know coming back down this cable, this is the cable from our horn and our light switches. We know the black wire is the positive voltage going up to the switches. We know the green wire is the positive voltage coming down from the light switch. And we know the red wire is the positive voltage coming down from the horn. So when this plugs on here, we can see the red side is for our horn, and that would go through the cable to that yellow wire on mine. Now again, on yours, just look for the wire because you may have red wires or different color wires. But this, you can look at the sides basically. If you're looking at it this way, the wire on the right, and on your scooter it will be probably like this, green, black, red. But on the other side, it might not be green, red, yellow like mine. So just follow the wires. So the right hand wire, this is the red one on mine, which we know is coming from the horn, would come through here and go to the yellow wire. The yellow wire goes one place. It just simply goes over and it loops into this other 3-pin connector on the left hand side, if looking at it from this, and then from there it would connect up to its cable and pass through. So we're looking for the yellow wire, which is the one closest to us, passes through to the red wire on this cable. And from there, the red wire goes up the cable to your horn. Okay, so this is a little circuit board that's in your headlight mount there. And you can see here's the cable. So the red wire coming up is our positive for the horn. And there's the black wire you can see, which is negative we talked about earlier. And that's how your horn gets activated, through that. It's already got the negative, and the red is the positive switch through the horn switch. Okay, so looking at this one again, now if we follow the other side on the cable from the switches, the green wire we know is the headlight and side lights. Okay, so when we plug that onto there, the green wire on mine goes to a green wire on the other side. On yours, again, it could be red, could be a different color, but it would be the wire that matches up to the green one on your scooter cable coming down from the switches. Now if we follow that wire, it first loops over and goes into the right side, the right hand side of this connector. And then if we plug on that connector, that goes up to the headlights and horn module, we can see that that green wire passes through to the green wire on this cable. So we know the green wire is the headlight voltage. Now if we look at this little circuit board again, we can see there's the cable, there's a green wire coming out, and that's going to the circuit board there. That's where your headlights are going to get their voltage at. So you could have a problem with the broken wire in here. That's another place you can check. From there is a connector. It's black and red wires, but it's really only a positive voltage. And it goes in series through these two lights. So let's just follow the red one comes through here, goes into the LED, comes out the other side of the LED, loops around, goes into the second LED, comes out that LED, back into this connector. So you could have a problem with those connections. And when you take yours off, notice how it's looped on there. There's going to be a wire that's kind of looped on there funny. But if you take it off, then just pay attention to how that looks. Okay, so that's how the voltage gets up to our headlight and Horde circuits. One last thing to do, and that's look at how the side lights tie in. Okay, so if we're looking at that same cable, it goes up to the horn and the headlights. It has the two wires. It has another wire coming out of it. So again, let's back up a second. The green wire coming through here, which is our headlight voltage, loops around, goes into the right-hand connector here, where it goes up that cable to the headlights. But there's also a second green wire that comes back out of there. And that second green wire loops over to the side lights. So coming through this connector from your switch, on the green wire, your headlight voltage, coming to that connector, both your headlights and your side lights are all tied to this right here. Then it goes into this connector, and that's where it splits. Your headlights go that way, your side lights go that way. So if you had a case where your headlights were working but your side lights weren't, you know the voltage is getting up to the headlights, so the voltage is right here, but it's not getting the side lights, so there'd probably be a bad connection on the wire going to the side lights. Likewise, if your side lights are working and your headlights weren't, you know that the voltage is getting here because it's getting the side lights, but it's not getting this way going up to the headlights. So you can use this as a guide. Again, it's best if you have a meter. You could follow the voltage through. Again, to do that, measure your voltage on this connector first. If you have your battery voltage there, you could then actually, we know our negative voltage goes to the middle pin of this one, and we know the positive voltage goes to the middle pin of that one. So you could hook your meter to the middle pin of that one and the middle pin of this one, and you should measure your battery voltage there. If you do, you know your battery voltage positive is getting this far, you know your negative is getting that far. The next thing to do would be to troubleshoot your switches. If your horn works but your lights don't, then you know it's up here in this module, because if the horn's working, the voltage is getting up to the switch. But if the lights don't work, then the voltage isn't getting from here through that switch or down the green wire. So you can just follow it over. Likely the problem will be right up here. Probably not even a bad switch, most likely a broken wire here or here. So those are just some tips there. You should then be able to, if you turn on your light switch, you should be able to measure your voltage. You'd have to have this one connected, of course. You'd have to have that one connected up. But then if with your light switch on, you should be able to measure between the black, which is the middle pin, and the green, which is the outer pin, and get your voltage there, because that's where it goes up to the headlights or to the side lights. So if you didn't get your voltage there, you would know it's back this way through this cable somewhere, or more likely up in the switch module. That's pretty much it. It's really just a pretty simple switching circuit. The negative voltage passes through to the side lights, the headlights, and the horn directly, and the positive voltage goes to the switches, one side to the horn, the other side to the lights, and then side lights and headlights split off on this connector, headlights going up the cable, side lights going over to here. Okay, so now I'm going to show you how you can hook the wires up without the use of this octopus cable. So again, an example where maybe your cable's missing, you got a used scooter and this cable wasn't in there, or maybe the cable's damaged or burnt or something to that effect, and either you want to make a new cable by buying all these connectors, which to me seems like a hassle. If I were in that predicament, I would just hardwire it. But either way you want to do it, you should be able to do that after watching this part here. Okay, so let's pretend like I don't have this cable, it's gone. Okay, now what we got left here is 5 connections. Now I don't have the side lights on the scooter. I removed them because I have an LED deck and the side lights distracted from that, so I physically removed them. But basically you'll also have 2 side light connections. They're going to have red and black wires, and it's going to be a 2-pin female connector on your side lights. 5 connections you're looking at. The one coming from controller with your power, and that comes right off that pigtail, off the alarm. Follow the red wire out of the alarm, where the alarm plugs on, and it will lead to both the display connection and to this pigtail. So you start there. Red is your positive, black is your negative. That's one of your connectors. You have your two side light connectors, 2-pin females with red and black wires. So that's 3 connectors. And then you have your male connector going up to the switches, your 3-pin male and your 3-pin female going to the actual lights and horn. So those are your 5 connections. So we got our red is positive, black is negative. Let's work with the black one first. It goes to 3 places. You would need to connect this black wire. Either you could cut, if you're just going to bypass these connectors, you could cut this right off and then just hardwire this black wire to the black wire on the 3-pin female. That goes up to your horn and your lights. So you would hardwire the black wire coming in to the middle pin, which is the black wire of this guy. In fact, at that point, again, let's assume we've cut off these connectors. Now you have to keep track of which one's which, because if you cut off the connectors, these are going to look identical, these 2 wires. So right now the only way we can tell them apart is there's a 3-pin female and a 3-pin male. So if you're going to cut these off, before you do that, I'd put a piece of tape on each one and then label them and just write something like, okay, the 3-pin male we know is going up to the switches. So put a piece of tape on here and write switches, or S just for switches. The other one you could put a piece of tape on and label it, this one goes to the lights and the horn, so you could label it L/H or lights, or just something to distinguish it. Really, if you have this one labeled switches, the other one has to go to the lights anyway. But definitely do that, because again, if you cut these connectors off, you'll see both of these will then look the same: red, black, green, red, black, green. So you wouldn't be able to tell them apart. If that happens, you could figure it out by using your meter to measure resistance. And we know that the horn, for example, is the red one coming down, and the black would be the positive. So you could disconnect this, or have, when you have this cut off, put your own meter across the red and black, measuring resistance, and then hit your horn button. And then if this is that cable, you'll see a short or a connection on your meter. Whereas if you're on the wrong one and you do that same thing and you hit the switch, it's not going to show any connection. So that's one way you can tell if you happen to mix these up and you got the connectors cut off. But again, better to just, before you cut them off, find the 3-pin male and label that one switches, or S, and then the other one will go to the lights. Okay, so here, just for example, I've labeled the 3-pin male connector with an S for switches, so I know that that's the one that goes to the switches. And I labeled the other one L for lights, that meaning that goes to the lights. It also goes to the horn, but you get the idea. So now at this point, if I were to cut these 2 connectors off, I could still tell which one's which, and that's very important that you know which one's which. The other thing I was talking about is, like, let's say this connector was cut off and I got these 2 mixed up. Right now I'm probing. I have my meter, I have it set for resistance. I'm measuring open. That's what an open circuit looks like. And I'm measuring between the middle pin, which is the black wire, which would normally have a voltage on it if we were connected up, going up to the switches, and then I'm on the red wire, which is the horn, coming back down. So this is where you can test your whole path up through the switch and back down. I'm now going to just push the horn button, and we'll look at our meter, and when I push the horn button, you can see it shows 0.8 ohms, no resistance, it's a connection. Let go of it, push it. So that tells me right now my horn button, my horn switch is working, and the black wire is going to where it should on the horn switch, and the red wire is going to where it should on the horn switch. You could also test the light switch in the same way by simply moving leave the black wire, or leave the black one on the black wire, because that's common to both switches, but move the red wire, or the red probe from the red wire over to the green wire, which is for the lights. So now I've got the red probe on the green wire, the black one's still on the black, and that we look at our meter, it's open. Now when I turn on the light switch, this should go closed, and it does. So that's confirming our path all the way up. The black wire, the positive going into the switch, is getting to the light switch, and it's coming back down the green wire and getting out this connector. So that's a good test you can do too if you have a meter and you're not sure where your problem is, you can easily check this whole wire and the switches like this. Okay, so again, black wire ties directly to the black wire of the 3-pin female. It also ties to the black wire of both your side lights. Now again, I don't have a connector on mine because I cut these off. I removed these from my scooter. But it'd be a 2-pin female, and you can see there's a black and a red. So the black wire of each of your side lights, and the black wire, which is the middle pin of the 3-pin female, all three of those places go to that black wire right there. If you connect all that, you're done with the black wire at that point. Okay, so now the red wire coming right in from the controller here, it only goes one place, and that's if you pick up the other connector, which is the 3-pin male. Now this could sound a little confusing, but you got to do it this way, trust me. The red wire, which is your positive voltage coming in, that red wire needs to connect to the middle pin, which is black on this 3-pin male. So your red power in goes to the middle, which is the black wire. And I know that goes against everything I've ever known about electronics, red and black, negative, positive, you shouldn't do that. In this case, it's the way to do it. The red wire is your positive voltage, goes to the black wire on the 3-pin male. That black wire goes up to your switches. It goes to each side of the one side of the horn switch and one side of the light switch. So you have your positive power just sitting there on the switches. So when you hit the horn and hit the light, it sends that power on back. Okay, so that's all the places for this main connector. Let's just review real quick. The black wire connects to the black wire of each of your side lights. And it also connects to the middle pin of the 3-pin female. And that's it. The red wire coming off your controller, which is the positive voltage, connects to the black wire of the 3-pin male connector, and that's it. It goes nowhere else. Just straight from the connector, one place, the black wire of the 3-pin male. And that gets your voltage up to each side of the switch, your positive voltage. Okay? Okay, our next connection, we're going to deal with the horn. From the video, we know that the red wire is the horn voltage after it passes through the switch, and then that connects over to, and that's the red wire of the 3-pin male, that connects over to the red wire of the 3-pin female. So at this point, you would just connect the red wire of this one to the red wire of that one. The two 3-pin connectors, one male, one female, connect the red wires, and you're done with that. Okay, next, the 3-pin male side green wire, and we know from previously that that's the voltage for the headlights coming back down after it's switched. So the green wire of this, again, connects to the green wire of the other 3 pins. So both the 3 pins, the 3-pin male, 3-pin female, connect the green wires together, connect the red wires together. Do not connect the black wires together. That's a totally different thing. Just do what I did previously up to this point, and you're fine with that. So again, tie the red wires of the 2 3 pins together, tie the green wires of the 2 3 pins together. And then in addition, one last connection, you also have to tie these 2 green wires that are tied together on these two to the red wires of your side lights. And at that point, you're done. It's not really that hard. Let's just go really quick through it one more time. Main connector coming off the alarm that has your power on it. Black is negative, red is positive. Tie that black wire to the black wire of each of your side lights, and also to the middle pin, which is the black wire of the 3-pin female. The red wire coming off the controller is your positive voltage. Connect that only to the one place, which is the black wire of the 3-pin male connector. And that's going to result in looking like you have a red wire going to a black wire. But again, that's the case. Just make sure the red wire is going to the black wire, which is the middle of this 3-pin male connector. So basically both of these connectors have a black wire in the middle. The male one is where you put the positive voltage, the red wire. The female one is where you put the negative voltage. The black wire goes straight through to the female one. Okay? Then again, your red wire on this connector, the male 3-pin, tie that to the red wire of the 3-pin female, and you're done. That's your horn. The other one, the green wire of the 3-pin male, which is your lights after the switch, tie that to the green wire of the 3-pin female, which goes up to the headlights, and also tie that to the red wires of each of your side lights. At that point, you're done. Hope that helps some people out there. If you got any questions about this, drop me an email and I'll help you out. All right, guys, take care.